So these three things you will be studying here. The continuous one is the continuous beam. Second one is the plane frame analysis. Third one is the three-dimensional frame analysis. Everything is rigid frame only. We are going to analyze. But we are not going to do the pin joint frame. So this is a continuous beam for which you are going to find out the membrane forces and the displacements, everything using the stiffness method. So the first one is the direct stiffness method. Direct stiffness method. Can you draw this diagram? Can you just draw this diagram? Continuous beam diagram. Once you finish it, you tell me. Somebody tell me. If anybody hasn't completed, then also you tell me afterwards. I will just wait for a moment.
Finished, ma'am.
Finished. Okay. So this is the beam. This is an example. So after taking any structure, you have to number it. So whatever I have circled it is how many elements are there in the beam. If you split it, this is the first one and the second one and the third one. There are three members in the continuous beam. Continuous beam means more than two beams. We call it as continuous beam. More than three or more supports, we call it as continuous beam. So first you number it as 1 2. Are you able to see the cursor? 1 2 3, they are the member number. And something else also I have marked it as 1 2 3 4 5 6 1 2 1 2 3, this is 3, 3, this is 4, uh, 3 4 5, this one is vertical is 5 and this rotation is 6, this is vertical is 7 and this one is 8. So this, can you note it down? That is, draw this diagram. First you mark the member. Member is 1 2 3. This three members are there and the title is node numbering. No nodes. How many nodes are there? At the left support, one node, second node, third node, fourth node. So each node will be subjected to, it will have a vertical translation and a rotation. Rotation I have given us 2 arrows. So that is, each joint will have a vertical translation and a rotation. This will have a rotation, vertical translation and a rotation. Fourth also will have vertical translation and the rotation. So, but sometimes some things will not be allowed. You take your scale. Better understanding. You take your scale, again put it in your finger. That is just on the top of your two fingers, two hands. You take a scale and use your finger. You put the finger on the bottom of the scale and hold it. So that type of uh, the connection we call it as, what is that? Support. That type of support, what we call. There are different types of supports: fixed support, hinged support. Then what is that? Hinged or simply support, roller support. Can you note it down? Different types of support. Note down the different types of support. First one is the simply support. Simply support. So yesterday we have learned how to find out the reaction of a simple support and beam. So first one is the simple support. Second one is the fixed support. Third one is the roller support. Roller support. So if I can keep the scale in such a way that it acts as a simple support. Just I'm putting my finger at the bottom of the scale means it's a simply supported. Just I'm holding it. The same thing, the same scale, I'm holding with all the 4 fingers, all the 5 fingers on one side, and the other with the help of the other hand, I'm holding all the at the end with the help of my finger. The other end also I'm holding it. So it will become a fixed support. Am I correct? Are you able to agree with me? Just I'm putting a scale, take your scale, scale what you are using in the class for drawing, that you put under, that is the top of the scale is below your, on your finger, 2 fingers, you stretch it out, and on the top of your finger, from the 2 hands, you put the scale, that's a simply supported. Then if the same scale, if I am holding it with the help of my all the fingers, the 5 fingers, then it will act as a fixed support. Can you imagine? Can you imagine what I'm saying? So in the case of in the buildings, there are simple supports, there are fixed support also. Suppose if the beam is resting on the wall, it is treated as simply supported. What is the difference between the simply support and the fixed support? Can anyone say? I'll just stop this and I'll come there. What's the difference between simple support and fixed support? What is the difference between simple support and fixed support? From the example of a scale itself, you try to say. So you are out there. That is, are you able to see me? There, oh, I can show it here. I'm just putting like the pen like that. You are able to see the pen I'm showing now?
Yes, ma'am.
Yeah. This is a simple support. Suppose if the beam, what you are constructing in the building is resting on a wall, that is the brick wall, then that is considered as a simply supported beam. So this is a simply supported beam. The same beam I can make it fixed. How can I make it fixed? Suppose if I am holding it like this, then I can make it as a fixed support. Then I can make it as a fixed support. What is the difference between these two? In this support, because of the I'm holding it firmly, nobody can put that joint down. No, if I put somebody is putting a load here, it will try to deflect. But this end will not deflect. The end that is we call it as J end and A end or B end. That we can't. That end will not deflect. Suppose the same but rotation is allowed. Am I correct? When I'm putting somebody is putting a load here, it will try to, the end will try to rotate. The end will try to rotate. Am I correct? Because I'm just holding it, it will rotate. One time I have seen when I was going to Kalpakam, I've seen a bridge failure. A bridges, it was a simple supporter bridge pier, and the bridge just deflected. So with the naked eye, I was able to see that rotation, but there was no deflection at the end. Maybe deflection would be maybe at the in the middle, but at the end there was no deflection. The same beam I can make it as a fixed one. How can I make it a fixed one? If I'm holding like this, it will become a fixed one. Now rotation is also not allowed. Then translation is vertical. Translation is also not allowed. So this pen I can move in the downward direction. I make it a downward direction, vertical direction. I can move it in the horizontal direction. I can move it in the Z direction. So this is the with this we call it as translation. Can you put it in your note? 3 different types of translations. Translation is movements, that is placements. That is, this pen can move in the vertical direction. This pen can move in the horizontal direction and the Z direction also. So write down. Translation is displacement along X direction. Write down. In multiple choice questions, you can that is, if I am asking what are the different the 3 types of translation means. Translation is displacements. You have to write as horizontal displacement, vertical displacement, and displacement in the Z direction. So that is displacement along X direction. It can move in the X direction, it can move in the Y direction, as well as it can move in the Z direction. Z direction is towards me. So like, can you put it in a note? Displacements or translations. Other word is displacements or translations. Translations. TRANSLATION. Translations. So translations are movement in the X direction, Y direction, and Z direction. Then there are three types of moments also, that is rotations also. One is moment about z-axis, moment about x-axis, moment about y-axis. So that x-axis moment we call it as torsional moment. The other two moment, that is moment about y-axis and the z-axis, we call this bending moment. So can you put the title as moment? Three types of moments, bending moments. Not bending moment, moments you write. MOMENTS. So one is the moment about z-axis. Write down moment about z-axis. Second one is moment about y-axis. Third one is moment about x-axis. Within bracket you write x-axis moment, we call it as torsional moment. What is the difference between the bending moment and the torsional moment? So this beam, suppose if I take, this is my beam, let us take this as my beam. Are you able to see this paper? Let us take this as a beam. This is the beam. So it will, because when the slab load is acting on that one, it will try to deflect. It will try to deflect. So this deflection we call it as, this moment we call it, because of the bending only it is deflected. We call it as bending about z-axis. Bending about z-axis. The same beam, it can bend in this lateral direction also, this direction also. Are you able to see? That we call this bending about y-axis. Bending about y-axis. The same beam, I can twist it. Am I correct? I can twist it also. That is the torsional moment about x-axis. I can twist it. So there are three different types of moments and three different types of rotation. That is translations. One is the translation about x-axis. Another one is translation about y-axis and translation about z-axis. And two more moments are also there. So what you have seen here is, because why I'm talking is, depending upon the type of support, this translation and rotation will be restrained. For example, this is a fixed support. You are able to see the cursor now. The first one is a fixed support, and second one and the third one are the roller support and the joint 4, the node 4. The node numbering I have noted now, 1, 2, 3, 4. The joint 4 is the fixed support. Can you note it down? Can you note it down in your note? Joint 1 is having a fixed support. 2 and 3 roller support. Fourth one is again a fixed support. Fourth one is a fixed support. So this joint 1, this is a fixed support. What is the specialty of joint 1? It's having a fixed support. It will not deflect or it can't rotate. Am I correct? So even though I have marked it, that is the deflection I have marked it as 1 and rotation I have marked as 2 for the joint 1. Then for the joint 2, can you tell me what is the numbering for the joint 2? For the joint 2, what is the displacement numbering?
3.
3. Rotation numbering? 4. For the joint 3? Joint 3? It is, I didn't mark, it is missing. Actually, it is 5. It is 5. Displacement numbering is 5 and rotation numbering is 6.
6.
And for the joint 4, rotation numbering is the displacement numbering is 7 and rotation is 8. 7 and 8. 7 and 8. So this you have to, if you have learned, means 10% of your first unit is over. How to number it, and can you tell me this one translation 1 is prevented? Am I correct? It is not. It is restrained. Prevented means, other word for technical word is restrained. Can you write it? Can you write it down? prevented. Other word is restrained. Prevented or restrained. Prevented or restrained. So number 1 is restrained. Am I correct? Number 1 is restrained. What about number 2? Restrained or free? It is free to move or restrained? Fixed support. It's a fixed support. Fixed support it is? Restrained. Just now only I have shown with the pen. No. That is fixed support means just now only I have shown. That is I'm holding this paper. Suppose if this is the paper. I'm holding this paper like this means it can't rotate at the end. Maybe in middle it may deflect, but at the end it can't deflect. The same paper, if I'm keeping like this, it to the end also will try to rotate. That end also will try to rotate. So can you put it in your note? Can you put it in your note? Dry fixed support, dry fixed support. So we will, if you want to tell in the words of pictorial representation, this is the representation for the fixed support. So fixed support, put a fixed support, right? There is no translation, vertical translation. There is no vertical translation. Or you write vertical translation is restrained. No translation, vertical translation, or you write vertical translation is restrained. Vertical translation is restrained. Then in that fixed support you write rotation is also restrained. Rotation is also restrained. Then you draw a roller support. Then you draw a roller support. Here it can't move vertically. Have you ever seen the roller support anywhere in the construction? Simply supported, I told. That is, when a beam is resting on a brick wall, then it's a simply supported. Can you say an example of a fixed beam? Can you say an example, practical example? Because whatever we are learning is a practical thing only. Just we are, instead of putting in the, like you have drawn the plan of a building, the plan of the building you have drawn, and whatever in the real construction you have put it in the form of a line in your paper. So like that, whatever practical things are there, only we are translating in terms of pictorial representation. So have you ever come across the roller support? Practical application of roller support. You might have definitely come across that, but you might not have noticed it.
Bridges.
Have you noticed? Bridge, very good, very good. That is bridges, rollers here after when you go, that is the piers on the top of the piers, you can see rollers. The rollers will be provided. The purpose of rollers is to allow the horizontal displacement to move a little bit in the horizontal direction, but it will not allow in the vertical direction. So when the bus is moving over the bridge, so there's a small amount of horizontal movement. You can note it, may not be with the naked eye, but some instruments are there. That is cameras, the special cameras are there to capture the or translation movement of the bridges. So that's example for a who told Jagan? I think Jagan. Am I correct? It's good. It's very good. So roller is an example. So roller, horizontal display. Write down. Put a title as roller. Draw the second one is the roller. In this picture, the second one is the roller. So draw a picture of a roller. Or so roller. Vertical translation is prevented. Write down. Restrained. Prevented or restrained. Vertical translation is restrained. But what are the things free? Rotation and horizontal displacement. Horizontal translation is free or not restrained. Horizontal translation is not restrained. Horizontal translation is not restrained. What about rotation? Rotation is restrained or not?
Not restrained.
Not restrained. Not restrained. not restrained. What can you, Jagan, can you tell me the practical the thing of the fixed support? What about the beam column joint? Beam and the column will be cast monolithically on a single day, and it will act like a fixed support. So beam column junction is a fixed support, and there will not be draw a fixed support and write, draw a fixed support and you write vertical translation prevented or restrained. Vertical translation restrained. Rotation also restrained. Rotation also restrained. So in the case of beams, we won't talk about the horizontal translation. In the case of beams, we won't talk about horizontal translation because the beam will not, as such, it will not deflect in the lateral direction. Lateral restraints are more, resistance is more, so that it will not move in the horizontal direction. So only we are considering only two things. One is the vertical translation, another one is the rotation. Have you understood what you study? Somebody can explain me today. Jagan, can you start what you learned? Because this is a basic thing. What you learned, can you refer from the note and tell me what are things we have learned today? Because if you should know about the support, fixed support, simply supported, and the hinge support. These three types of support, and what is restrained and what is free, you should know. There is a word called restrained, and there is an opposite of that is free. So it is free to move. So it is something is restrained. So like that you should know some example of what some qualities, inherent qualities of different types of supports. So can you start, Jagan, what we learned today?
Yes, ma'am.
Tell me.
Two types to find the member forces.
Yeah.
One, moment distribution. Second one is slope deflection.
Okay. And this we are studying about the direct stiffness method. Am I correct? Direct stiffness method. Yeah.
And also another three types for direct stiffness method: continuous beam, plane frame analysis, three-dimensional frame analysis.
These are the things we are going to do in this semester using direct stiffness method. Very good. Then next one is, can somebody else explain me? I think Kritika, I won't disturb today because she has joined today. What about Sweta? Can you tell me the remaining things what you learned? Tell me.
We learned about the determinant and indeterminate structures.
Yeah.
And type of supports and type of translations.
What are the types, different types of three different types of supports are available?
There are three, and simply supported, fixed, and roller.
Roller support. What is the specialty? Tell me.
And for the translation, we have a horizontal displacement, vertical displacement, and Z direction displacement.
Displacement. Okay. Then rotation. Many moments. Moment about
y-axis, z-axis, and x-axis.
X-axis moment we call it as
torsional moment.
Torsion moment. Twisting moment. Twisting moment. That is best example I can tell when your cloth are wet. How will you squeeze the water? How will you squeeze the எப்படி துணி Tamil everybody can understand?
Yes, ma'am.
Yes. Okay. Tamil சொன்னா how will you have when the cloths are wet, you want to squeeze the water out, what will you do? அப்படியே one direction you will give clockwise moment, and the other direction you will give the anti-clockwise moment. Am I correct?
Yes, ma'am.
Generally water will come out of the cloth. That's the best example of is the x direction moment. You won't rotate the cloth in the same directions. If you are rotating the cloth in the same direction, then the water will not come out. So one hand you will rotate in the clockwise direction, other hand you will rotate in the anti-clockwise direction, so that twisting takes place. Am I correct? Twisting takes place. That moment we call it as, that is with the help of the finger also, with the help of the hand we are giving some force to the wet cloth. Am I correct? That force we may not be able to calculate, or that is you can calculate mathematically, but physically, as soon as you see this, how much force my hand is applying, you will not be able to tell. So some moment you are applying, you are able to understand what I'm talking about, the torsional moment. So when it is the cloth is in the horizontal direction, you are twisting in the one is in the clockwise direction, and the other hand is the anti-clockwise direction. Hereafter, when you are doing that particular thing at home, you just feel it. You have a feel of that. That you tell your mind that I am applying a torsional moment to the cloth. That's why the water is getting squeezed out like that. Really, the practical beam also can be subjected to torsional moment also. That is, if it's unequal, that is one end of the beam is having a clockwise moment and the other end of the beam is having a anti-clockwise moment, it will be subjected to a torsion moment. So we have learned about 3 moments and the 3 translations. Then can you tell something about the 3 different supports what you learned? We have learned about fixed support, simple support, and the roller support. What are the speciality of these 3 supports? Please, can you please tell me? Kritika, can you try what about fixed support?
Yes, ma'am.
Yeah,
Fixed
tell me.
support is rotation is restrained.
Rotation is?
Restrained.
Yeah, very good, very good. Rotate restrained. It is not allowed. Rotation is
And
restrained. Then
vertical translation is also restrained.
restrained. Very good, very good. Then what about the simple
Roll,
support?
simply support rotation is free.
Free.
Yes, ma'am.
Rotation is free. Then translation, vertical translation. Simply support. Simply support. You hold with the what is that? Scale with the finger. It is not allowed at the end, no? It can't deflect downward. Yeah. So it is sustained.
Restrained.
Yeah, roller support and simply supported. But here, as far as the beam is concerned, it is same. Simply support or roller support. That is vertical translation is restrained.
Horizontal and rotation is not restrained.
Yes. Very good, very good, very good. So you understood the concept that the 3 different supports. The practical thing, the fixed support is beam column joined. Simply supported is when the beam is resting on a brick. Have you ever noticed the beam resting on a brick? In my house and all, we have constructed, it's a non-load bearing structure only. It's not a frame structure. So we have built a frame. One end of the, we built a beam in the car parking. So the one end of the beam will be resting on the wall and the other end is on the column. So it is what is that? A propped cantilever. Have you come across the word propped cantilever? Propped cantilever. Cantilever beam. Cantilever beam. Have you heard of the word cantilever beam?
Yes, ma'am.
What is that cantilever beam? One end of the beam is fixed
One
and other
is
end is free. Free. Propped cantilever means one end is fixed and other end is propped over. Propped means simply supported over the some end. So in my house, same thing happened. That is one end of the beam is supported on a column and the other end is resting on a wall. So wall means it's a simply supported. So it's a propped cantilever. That is one end is fixed and the other end is cantilever. Now you understood what is the practical difference between the fixed support, simply support and roller support. Have you understood or not? Can I hear from Sweta? What is the difference between? Yeah. So what about Kritika?
Yes, ma'am, I understand.
Yeah. Because why I'm stressing all these things these are very important to formulate the stiffness matrix. I thought of going a little bit faster, but the basic concept, Jagan, you have to do me a favor. Before tomorrow morning, first of all, we have a class at 8:30. You should make what is that? The color arrest to understand what I have taught today. Can you do it? You can teach him over phone. This MS team also you can join and teach him. You can come in the same code, and you can ask him to join and teach him. Otherwise, he may find it very difficult to pick up. If this basic concept is missing, then it will be. You need a record, of course. I'm recording it, but when you are teaching him, you need not record it, but somehow you try to teach. Okay. Jagan, can you do this favor for me? Yeah, okay. Then we will try to move on to the formulation of the stiffness matrix. So this picture you have finished drawing. Have you drawn?
Yes, ma'am.
Yes, ma'am.
You finished? No, finished. No, I'll move on to the next thing. So here one thing is missing. 7 and 8 are missing. Sorry. 6, 7, 8, 9. No. This
5 and
is
7, ma'am.
5 and 7 are missing. Just note it down. Just note it down. And in the next class, I'll make it corrected. So now we are going to take one beam alone. Here, this when you look at this continuous beam, you have 3 beams. 1, 2, and 3. 1, 2, and 3. 3 beams are there. Now I'll move on to a single beam. I want to arrive at the stiffness matrix. Can you draw the beam once again? Can you draw the beam once again? That is one member alone I have drawn. I have taken and drawn. So if you are very thorough about this first unit, the second unit is your programming unit. You have to write a program, or so you have to. If you learn the fundamentals only, you will be able to write the program. So the first and second units are based on the stiffness matrix method. Third, fourth, and fifth unit are your final element analysis method. So shall I move on to the next slide? So put the title as formulation of stiffness matrix. Of course, we will not be able to complete it, but just to draw the diagram, I'll show in the slideshow mode. Draw the diagram. That is, I'm applying. This is a one single beam I have taken. Then the previous slide we have drawn. No, tell me.
Can you once again show me the previous slide?
Previous slide, definitely.
Okay, ma'am.
If anybody wants, then you have to start me because I won't be able to see your faces. So here this picture, using this one, I'll be explaining about the formulation of the stiffness matrix. That is, you might have learned in BTech itself, external load is equal to, that is P is equal to K into U. Are you able to recollect something? P is equal to K into U. P is the external load and K is the stiffness and U is the displacement. You might have learned definitely because you have learned the stiffness matrix method. It's a mandatory thing in Anna University. So you might have definitely learned. So arrive at the stiffness matrix because P is equal to K into U. How to formulate the find out the stiffness of this one we are going to study. So what I have to do is first I have to take the small beam. Both the ends are fixed. The ends of the beams are fixed. It is having a the vertical translation and the rotation. It is prevented and here the vertical translation and the rotation are prevented because it's a fixed support. Now what I'm doing is deliberately I'm giving a unit displacement to the left end. So when I'm giving a displacement, I'll just go back to the this one and I'll explain. Suppose this is my beam, are you able to see? This is my beam, I'm holding it, both ends are held together. But deliberately now what I am doing is I am giving a unit displacement to the on the top. All of you take your pen and do as I'm doing now. That is, then only you will be able to feel the force developed on your right hand. I'm giving unit displacement. That is, I'm making the left end to move by 1 centimeter. 1 centimeter. Now, because the right hand is giving a fixed support, fixity, it's feeling some forces. It is not allowing. It is this end is I'm lifting, but the right end, it should not be get lifted or rotated out. In that case, I'm able to feel some forces. All of you do it and feel the force developed in your right hand. Just to do it with your pen. Stop writing. Can you switch on your video? Let me see. Switch on your video and let me see that you are doing with your pen. All of you switch on your video. So hereafter, for attending the classes, you have to dress well and you have to sit for the classes as if you are coming to the college. You can do it or not? You are not prepared. Jagan? Hello?
Yes, ma'am.
Yeah, do it. Open your video. Can you do it or not? I have done like that.
Ma'am, your window is too small, ma'am. I can't see properly.
Yeah, okay. What you have to do is now you are able to see my finger. Otherwise, now we are able to see the pen. You are not able to see the pen. You are not. This paper you are able to see. You are not able to see.
Yes, ma'am.
Yeah. So what I'm doing is this, both the ends are fixed. I'm holding it like this. Now deliberately I'm giving a unit displacement to the right end. So if you're doing with the pen only, you can feel the pressure. That is, this is the pen. I'm trying to lift the pen by unit displacement. That is 1 centimeter I'm trying. So when I'm doing like this, right hand will feel some forces in the right hand. Do it now. Sweta, can you do it and show me?
Yes, ma'am.
Yeah, do it now. All of you should do. Then only you will understand, enjoy the subject. Yeah. Yeah. Are you able to feel the pressure?
ma'am.
You are able to feel the pressure. That is some force. Am I correct? Kritika, did you try your pen? Did you
Yes,
pen?
ma'am. Yes, ma'am.
Can you do it? I didn't see your face. I want to see your face also. Can you do it? Yeah. Okay. So when you are doing like that, you will be able to see it. What I'm going to do is I'm going to do something like that.
Priyanka.
Yeah. So I'm deliberately giving a unit displacement. I have marked here as 1. At the joint, I have noted the joint is J and K. The joints are J and K. It's a beam. It's having a joint J and K. So at the joint J, I am giving a unit displacement. I think time is over, no? Time is over. 1 more minute is there. I'll just explain and then we can take it the next class. Tomorrow, first hour, we will do some test. Kritika, you learned from either Jagan or Sweda what you learned, and you can take some small quizzes of what you, for example, what is the unit of shear force, what is the unit of bending moment, and today what you learned, what's the fixed support, and what is free and restrained. All these things I'll conduct a small quiz tomorrow. It's a small test. You need not study much, and how to find out a reaction of a simply supported beam when uniformly distributed load is there, and when what is that concentrated loads are there. So you have to learn something and come. Even if you commit mistake, no problem, because it's the first test. Or if you want, I will conduct a retest also, no problem. You learn something from them and you can come to the class. So when a unit displacement is applied, just you have felt some forces here. That forces we are going to find out now what is happening. So you have already derived that derivation and all. I am not going to do it. So when unit displacement is coming, how much is the vertical for shear force you are able to feel? 12 EA by L cube on the left side. Left side also you should prevent. Somebody is trying to push it by 1 centimeter, but you are trying to push it in the downward direction. So some force will be developed in the left side also. Somebody is pushing up, but somebody is trying to keep it in the original position. So the force will be developed. What's the force developed? 12A by L cube. Then here are the rotational force, the rotational bending moment developed will be 6A by L square. Then the other end, when you are applying the force in the left end, you are able to feel something in the right also. That is equal to 6A by L square and 12A by L cube. The vertical force is somebody is pulling upward. I am applying a upward force. So the right hand side, to keep it in the original position, somebody should push in the downward direction. So that is the 12A by L cube and 6A by L square. Similarly, I can apply a unit rotation. When I am applying a unit rotation on the left hand end, what are the forces developed? That will be equal to 6A by L square, and the bending moment is 4A by L, and to other end 2A by L and 6A by L square. So in detail we will learn in tomorrow's class. I think we will stop with that. If any doubt you are having, you can ask me. Are you having any doubt? Jagan, are you having any doubt in this what you learned today?
Ma'am.
Any doubt is there for you?
Ma'am, tell me one example for a fixed support in real life.
That's what I told. No? RCC beam, the beam and the column. What type of support?
Voice is breaking.
Voice is breaking. Yeah. In the beam column junction is a fixed support. Am I correct? Beam and the column, the beam, when you are making it, what you will do is the beam from the reinforcement from the beam will be taken to the column. Am I correct?
Yes, ma'am.
And you are in the construction field. The beam or the column junction, they will make it on the same day. Am I correct or not? That is called monolithic construction. The joint will be made on a single day. Concreting, they will pour it on a single day. No. Am I correct or not? Yeah, that's a monolithic construction. That the reinforcement from the beam will be taken to a development length to the column, and the concreting also will be done on the same day. That we call as fixed support. What's the meaning of that? There will not be any rotation. There will not be any rotation, or there will not be any vertical translation. So the best example is a beam column joint, reinforced beam column joint. What is the example for a simply supported? If the same beam is resting on the instead of column, if it's resting on the wall, brick wall, then it's a simply supported. That's the practical application. Any other doubt is there? Anything else is there? If nothing is there, then we can stop it. Sweda, you have any clarification from me? You want to clarify anything from me?
No, ma'am.
Kritika, are you able to follow?
Yes, ma'am.
Okay. So remaining things you will learn from Jagan, and tomorrow we'll have a small course. And one humble request for Jagan is you have to teach colors some more. Okay? What you will learn today.
Okay, ma'am.
Okay. Okay. Thank you very much. Find out why is morning class he has attended.
Yes, ma'am.
Then what happened to him?
Ma'am,
He
he
didn't
told
know.
some network issues.
Some
Network issues.
network issues. Okay. Then you can teach him over phone. Okay. Because for you 75% attendance is mandatory. So ask him to attend all the classes. Okay. So for Kritika, the attendance will start from today only. Okay. Can I leave?
Okay, ma'am. Thank you.
Okay. Thank you. Thank you
Thank
very
you,
much.
ma'am.
Thank you. Yeah. Thank you. Thank you.